Hello and welcome to this video on compound inequalities. Compound inequalities are two inequalities joined by either and or or. If I have an and statement, I could write the inequality as something along the lines of 2x plus 1 is less than negative 3, and, which is often abbreviated as the intersection, okay, meaning and, you're looking for where things cross, and something like, I get rid of this line, 3x plus 4 is greater than 2. Okay. What I can also write an and statement as is something like negative 5 is less than or equal to 2x plus 5, which is less than or equal to 6. Okay. What you will notice is anytime I have an and statement joining two statements, I pretty much will almost always have this less than and less than. This is what's called the three-part inequality, and it's always representing an and statement. If I have an or statement, I might have the same statement, 2x plus 1 is less than negative 3, but it's going to be joined by an or, which indicates the union, okay, which we symbolize by sort of a right side up U. We're looking for where do the two segments, in a sense, we're looking for sort of the solutions of both, and looking for where do they, where is there any shading at all. So it's or 3x plus 4 is greater than 2, for example. Okay. So how do we go about solving these? You're going to solve them pretty much the same way. I'm going to show you some examples, but I just want to kind of go through what are the 6 categories of answers where you're going to possibly end up with. Okay. With the and statements and the or statements, there's going to be 3 possible solutions for each. Okay. Or situations where you're going to end up with. The first type of solution for an and statement is where you're going to end up with a solution where one solution to an inequality will face this way, one solution will face this way. You're looking for where do they overlap, where do they cross, which would be right in the middle here. So on the number line, I would keep what type of circles here, keep what type of circles here, and look for where they overlap. So for and, you're looking for the intersection, or where do the lines cross or overlap. Okay. Where are there two lines being drawn? Where do you see both the blue and the red? So what I normally do when I'm graphing the solutions is I will graph each individual solution above so I can see sort of where do they cross. Don't try and do it in your head based off the numbers. This is where the graphing becomes very important. And then look and say, okay, well, where do they cross? And that's where my solution is. The second type of solution will happen with the lines facing, so this is when the lines face opposite ways and cross. Okay. The second is dealing with what happens when they go in the same way and they overlap. Okay. This solution is usually whatever number's here. So like, let's say this is 2 and this is 5. I would say 2 is less than x, which is less than 5. So the 2 and the 5 in a sense form the boundaries. When they are going the same way, okay, so once again I might have something looking like this, and then I might have something looking like this, facing this way. They're facing the same way. Where is it that they overlap? They overlap here. So I'm going to keep the same type of circle that's there, and I'm going to shade this going in. So if once again this is in a sense 2, maybe here, and maybe this is 5. I would take the fact that this is x is greater than 2, and I would take the fact that this is x is greater than 5. Based off of my solution here, I would say that x is going to be greater than 5. This would be my solution. Okay? I'm not going to state both of these here because it's really only where this overlaps. So it's redundant to sort of give both the answers. So I stick with the answer given here. The third solution possibility is that there are no solutions whatsoever. Okay, and this is when they have opposite ways. The graphs face opposite ways. And it does not cross. So what my graph will look like is something like this, where if I stick with the 5 again, and then I might stick with the 2 again, they do not cross at all. So I would say my solution is the empty set. There is no solution, which would be a blank graph, and with the denotation here, or somewhere on your sheet, that there is no solution. So these are the and solutions. You're either going to have opposite ways crossing in the middle, so I've got my boundary points shaded in between where it overlaps. If they have going the same way, I'm looking for where do they cross, which would be the smaller sort of section, okay, of where they cross. Or I might have no solution where they don't cross at all. With and statements, I am looking for the union. So I'm looking to join all possibilities together. I'm taking everyone in. Everyone's welcome with or statements. Okay? As long as you got one color or the other, you're included. Okay? So if I go ahead and think about these, the most common is when they're opposite ways. And not crossing. This is probably for some reason the most popular with or. Okay. Where I might have one solution here like this, and my other solution might be here like this. So since I'm taking wherever shaded, wherever shaded becomes part of the actual answer. So in this case, I would take both sides. Our second statement comes from lines that are facing the same way and overlap. In this case, what we would have is something like we had on the left side, where I might have x is greater than 2, and I could have x is greater than 5. Okay. In the first part, or in number 1 for the or, I would write something like x is less than 2, or basically symbolized by the union of x is greater than 5. Okay, I can write the union or I can write the u. For the second possibility with or, when they're facing the same way, I'm going to look at where are all my possible answers. Okay, so I accept everything. Wherever I have one line shaded, it's as if they're both there. Okay, it's an acceptable solution. So I would take this whole entire thing, which then I would say would be x is greater than 2. I would be able to summarize it, condense it down into the one statement. Because as long as there is one part of the line shaded, the whole entire line is shaded. The third possibility is going to be when they are facing the opposite way and where they cross. So, for example, this is like number 1 of the and statement in many regards, where I could have x is greater than 2. So something looking like this. And at the same time, I could have x is less than 5. Okay. Since they are overlapping, I would have to take any place that's shaded. Remember, all are welcome. So I would shade down here, since it's shaded with the blue. In the middle here, I have both that are shaded, and off to the right, I have the red. So I would take this whole entire number line and would be shaded. So, and it would keep on going, okay, in both directions. So in this case, I would have all real numbers would actually be solutions to this equation. So there'd be infinite solutions, but more specifically, it'd be any real number would be considered a solution. So let's say for our first example, we have -1 is less than 5x minus 1, which is less than 9. So in order to solve this, it's an and statement. So I'm going to think about it as a three-part inequality. So whatever I do to one section, I have to do to the other two. So in solving this, let's say I add 1 here. Also means I need to add 1 there, add 1 there. Remember, the goal is to get x's by itself. So those cancel. I end up with 0 is less than 5x, which is less than 10. Divide by 5, divide by 5, divide by 5. I get a solution of 0 is less than x, which is less than 2. In looking to graph this, I'm going to think about it as x is greater than 0 and x is less than 2. So in graphing it, let's have -1, 0, 1, 2, 3. Okay? I could think about this as x is greater than 0 and x is less than 2. Okay, where do they cross? I'm going to look at them crossing right here in the middle. Okay, so my open circle would be at 0, my open circle would be at 2. I would fill in the middle. Now, once you get a little bit of experience, what you can also think about this, as long as it has the less than signs and the smaller numbers off to the left. 0, 2 are the boundaries. They're open circles since it cannot equal either of those. And I would fill in the x would be what's in between, what's in the middle of these two boundary numbers. Okay, so that kind of makes sense in either way, either method you want to take a look at it. Let's take a look at an or statement. Okay, so let's look at something along the lines of 3x minus 1 is less than 5. Or 1 minus 2x is greater than 4. Now let's make that 5. Okay, so I solve each of these independently. So I add 1, cancels, 3x is less than 6, so x is less than 2. In solving the other half of this inequality, the second inequality, be careful because all the rules for inequality still apply. So when I go to divide by -2, remember you're going to need to switch that inequality. So x would be less than -2. Remember, this is an or statement. So when I go to graph this, okay, I would get the x is less than 2, given here, and the x is less than -2 would be here. This would be the situation where they're facing both the same direction. But since this is an or statement, this means all are included. So I would start with the open circle here, and I would shade this way, because anything that's shaded gets included. Okay. If for some reason this was equals here, then I would fill in this circle. Okay, and then I would summarize my answer. Here my answer would get summarized as 0 is less than x, which is less than 2, would be the most simplified way of writing it. Over here on the right, I would write that x is going to be less than 2. So anyway, here's a little bit of an introduction to compound inequalities. This video is a little bit on the longer side. because this is a little bit more complicated. It's something that I'm realizing is new to you, which is okay. So we will be practicing it for a couple days in the coming week.